To begin with introduction, gravimetric analysis is a type of quantitative analytical technique in chemistry that involves measuring the mass of a substance to determine the amount of an analyte in a sample. Gravimetric analysis relies on precipitating a compound, filtering it out, drying it, and weighing the solid. Move on to the objective. First, to apply gravimetric analysis in determining the effectiveness of water filtration. Second, to measure the mass of total suspended solid in water before and after filtration. And lastly, to demonstrate the reliability and simplicity of gravimetric technique in assessing water quality. Now, let's move on to the theory. In the context of water filtration, gravimetric analysis can be used to determine how many suspended solid or dissolved minerals are removed during the filtration process. By measuring the mass of solid before and after filtration, we can assess how effective a filter is.
Now, I will be talking on the methodology of the filtration technique that is based on the gravitational filtration. Now, first up, we have to weight the dry beaker and the filter paper using an analytical balance. Secondly, we should fold the filter paper and place it into a funnel. The filter paper should be wet with distilled water, as this helps the filter paper to stick properly into the funnel. The funnel is then placed into a ring stand and it is positioned over a clean conical flask. The mixture should be poured gently into the funnel in order to avoid splashing of the mixture, and then the liquid is allowed to pass through the filter by gravity. Then, rinse the residue of the solution with small portions of the distilled water. Lastly, recover the filtrate and wait for it to dry, and wait the residue for it to be recorded in the results. As a conclusion, the gravity filtration technique successfully separates the solid impurities from a liquid mixture using the gravitational force. This method can be straightforward and it is also cost-effective, and it is also widely applicable in both the laboratory and also the industrial purposes.
For the results, the example question is a sample of filtered water was tested for its total dissolved solids known as TDS. Before filtration, the sample had a mass of 250 ml of water containing 500 mg of dissolved solid. After filtration, only 120 mg of solid remain. Calculate the percentage removal of dissolved solids due to filtration. To calculate the percentage removal of dissolved solids due to filtration, the first step is the initial amount of dissolved solids 500 mg minus with the final amount after filtration 120 mg, and you get 380 mg. To calculate the percentage removal, the amount removed 380 mg divided by the initial amount of dissolved solids 500 mg and times with 100%, and you get 76%. The findings result is the water sample initially contained 500 mg of dissolved solids in 250 ml of water. The high concentration indicate significant contamination or the presence of various soluble substances. After the filtration process, only 120 mg of dissolved solids remain. This means 380 mg of impurities were successfully removed. Therefore, the percentage removed efficiently was found to be 76%, showing that the filtration method was effective in significantly reducing the total dissolved solids. The observation that we get is the filtered water was clearer and less turbid compared to the original sample, and no visible particles were observed after filtration. And a measurable reduction in mass of solids confirmed chemical cleanliness improvement. This also suggests that the filtration system was efficient for removing dissolved solids.
Future recommendation. First, a smart environmental and control system that can maintain the consistent humidity and temperature. Future systems should integrate AI-driven feedback loops that adjust HVAC, deploy humidity, buffer trace, and log environmental conditions continuously to ensure filter equilibration and working stability. Second is hybrid analytical system that can combine gravimetric with the other techniques. Hybrid platform that pair gravimetric measurement within spectroscopy or imaging, example microscopic particle morphology that can validate composition and particle size distribution concurrently, boosting accuracy for complex water. And lastly, automatic and robotic to reduce the human error. Advanced laboratory robotics can automate filter transport between sampling, equilibration, and weighing station. Modern microbilance with barcode integration and feedback control ionizing neutralizers exist, but robust error handling and sample ID verification are needed to prevent mislabeling and mechanical jams. In conclusion, gravimetric analysis in water filtration is works by trapping particles on a filter, drying them, and then weighing the filter before and after. The weight difference tells us exactly how much solid material was in the water. This simple direct method gives clear number on turbidity and filter performance, helping us check for the contamination, judge how well the filter is working, and make sure our drinking water meets the quality standard.